check this question down and see if we can solve it. If we can't use this principle to solve, it's not possible. Because if you look at the question, you're going to see two metals there. One is silver, the other one is aluminium. So you see, so that's going to give you a clear indication that this is not the other aspect of Faraday. This is aspect that has to do with what? Two electrolytes. That is that of silver salt and that of aluminium salt. Connected in series, and both uses the same electricity. The mass of one substance, the mass of silver is given. So the same quantity that derived mass of silver will also be used to derive mass of aluminum. But in this question, we are looking for mass of aluminum. Okay. It's taking time. Okay, let's see. Now, I think I'm going to do it this way. A quantity of electricity liberates 3.6 grams of silver. Listen to me. Let this first mass M1, okay? Anyone can be M1, anyone can be M2. If I decide to make my silver M1, that is my choice. If you want to make silver M2, that is your own choice. But we're all going to arrive at the same answer. That's the beauty of it. You can even try it. You watch me use this as M1, okay? I can say, let's AG be M1. I can say, let AG be what? M2, whichever way, okay? Okay, M1 is equal to what? Is given now. I'm using, okay, let's say, let AG, that's silver, be what? M1, and the mass is given as what? 3.6. Are you with me? Okay, gram, in gram, good. Now, let's M1 be what? Mass of what? Mass of AG. Mass of AG. Let E1 be what? Chemical equivalent. Okay? Chemical equivalent of what? AG, which is 108. You know what I mean, right? Relative atomic mass is even given there. Divide it by 96,500, or divide it by what is charge on silver? 1. Divide by 1. It's cool like this. Okay, now let's M2 be mass of what? Copper, and it's not given. Are you with me? Sorry, mass of is copper? No. Mass of what? Aluminium. You can see there. Then let's E2 be mass. Oh, sorry, chemical equivalent, please let me use this short form of what? Al, which is, what's the mass of aluminium there? Is given as what? 27 over charge. What's charge on it? 3. Therefore, I'm going to apply M1 upon what? E1 equals to what? M2 upon what? E2. Are you with me now? So now, my M1 is 3.6 over this, Abby. So 108 over what? 1 equals to M2 is unknown over what? 27. Let's just do it by what? 3. So we have 3.6 over 108 equals to M2 over what? Over 9, isn't it? So we now have that M2 now is what? 3.6 times what? 9 over what? 108. What is my answer now? This one is just straightforward. Is what? 0.3. 0.3 what? Gram. Using first principle to solve this may take a lot of time, and then at one point can fail most often. I'm still going to explain that as well. This is formula method. One can solve using first principle kind of statement and method. Let's call it first principle. But that most time may not give you exam. It may give you something that you have to approximate to get to that. That's one thing with that method. But I'm going to do it in this class, so you can have variable options. So that's going to be the only example I'm going to do with Faraday's first, second law. Maybe in our class of past compiled past questions, UTME, SSC, screening, nursing, maybe I'm going to be solving more of problems on electrolysis. But for this class, that's going to be the only example for that. But I'm still going to use another method, which I refer to statements or first principle. Now, in the first principle, a quantity of electricity liberates this. Can you see this formula or see this kind of statement that a number of moles of, I don't know which one comes first there, silver, isn't it, over number of moles of which one follows suit, aluminium, is equals to charge of aluminium will now come first here over charge on what? Silver. But number of moles was not given. But you can find number of moles of the one whose mass was given. Which one was this mass given? Silver. So find number of moles. Number of moles of Ag is equal to what? Mass of Ag over what? Molar mass. So which is what? Mass is what? 3.6, I think, upon what? 108. What's my answer here? 0.03. We must get the answer. I want to know the number of trees that are there. How many trees? How many trees? Count the trees. How many trees? Count. Are you sure it's 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is it 10? If you don't get exactly 0.3, that's the answer. I think that's the answer using the formula method. Okay, that is that. The what I will now do now, I now know the number of moles now of silver. I'll say therefore, here will now be what? 0.033333333. I can approximate if I like. 1, 2, 3, 4, 5, 6, 7, 8, 9. Another 3 over number of mole of what? Ag equals to what is charge of an aluminium? What is charge of silver? 1. I cannot get this one now. Therefore, Al, that's number of mole of Al. Let me state it. Number of mole of Al is what? 0.33, sorry, 0.3333333333. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Thank God it's complete. Times what? 1 over what? 3. What do I have there? Remember, this is a mole. Is what? 0.0. How many ones? 10. 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, mole. This is mole of what? Aluminium. So you have to find a mass. Therefore, number of mole of Al is equal to what? Mass of Al over what? Molar mass. So I'm going to plug this in here now. This number of moles 0.01111111111. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, is equals to mass of what? Al. What's the molar mass of Al? 27. Okay, what's the answer now? So what's mass now? Mass is now 0.111. Sorry, 0.011111111. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Times what? What's the answer? 0. What? 3. But if we had approximated here, Suppose you approximated here to be 0.03, and then here you got 0.1, and then it says 0.1 times 7. You cannot get 0.3. That will give you 0.2 something, isn't it? 27, I think. So that's why, in this case, you don't do this and approximate. That's why it's a very old principle. First principle, old principle. So, but the new principle have come to salvage. So you just, and then get your answer. And before we